The Tround 50 caliber weapon system is a new, advanced concept which represents a major innovation in ordnance design. Based upon Tround International's open chamber technology, the simplicity of function of this system provides high reliability and improved maintainability in a lightweight, cost-effective package which delivers awesome firepower.
Go.
Let's take a more detailed look at the principles of function and capabilities of this unique weapon system.
The key to the Tround gun system is its open chamber technology. As illustrated here in cross-section, there are several non-circular cavities on the periphery of the gun cylinder. The ammunition case, whose geometry matches that of the cavity, is fed laterally into the open chamber. By indexing the cylinder, the live round is brought into battery position in line with the barrel and firing pin. The cylinder, which is controlled by the cam index drive, stops at this point during the combustion cycle. Following a short dwell time, the cylinder rotates again to eject the spent case. Each index of the cylinder simultaneously feeds and ejects a Tround. A unique feature of the Tround gun system is its use of a non-circular cartridge. Shown here is a round of 50 caliber Tround ammunition. Note that the ammunition has a triangular cross-section along its entire length. The word Tround is derived from triangular round. The projectile is telescoped within the two-piece plastic cartridge case. The propellant chamber can contain either conventional loose poured propellant or take maximal advantage of consolidation techniques for increased performance. Although weighing slightly less than a conventional brass 50 cal case, the Tround contains 50% more propellant volume. A standard percussion primer is inserted at the base. As currently configured, the Tround 50 caliber single barrel gun has a maximum rate of fire of approximately 2,000 shots per minute, with lower rates easily selectable through the gun control unit. The system comes up to full rate in less than 100 milliseconds. At present, the system yields 3,200 feet per second with M33 ball projectiles. With enhanced ammunition and a longer barrel, 3,450 feet per second has been demonstrated. Further performance increases are planned, utilizing consolidated propellants and igniter design improvements. This 50 caliber gun was originally designed for evaluation by the Gun Systems branch at China Lake Naval Weapons Center. Responding to a requirement for increased ammunition performance, interior ballistics modeling was performed and a cartridge case was designed. Finite element stress analysis was used to design critical gun components. Prototype ammunition was produced for firing in a single-shot firing fixture, in which all ballistic development was performed. Based upon these test results, an automatic gun was designed and fabricated to demonstrate the basic principle of open chamber guns. Subsequently, the gun system was modified to include a recoil system, pistol grips, and a novel ammunition handling system for evaluation as a crew-served, pistol-mounted weapon. In order to more fully understand the workings of a Tround gun system, the major components and features of the pintle mount 50 cal system will be described in the following scenes. Shown here is a conventional M2 heavy barrel, which has been modified by removing the chamber section and by threading for attachment to the gun frame. The frame is of box construction and forms the major structure of the gun. It houses the percussion firing pin mechanism, consisting of the firing pin and hammer at the rear, the operating spring and rod along the frame, and the safing mechanism at the front. This area of the frame is called the strap, which forms one side of the constraint for the ammunition while in battery. The other major component is the gun cylinder. 4 Tround-shaped cavities form the firing chamber for the ammunition when rotated into battery. Here, a dummy Tround has been inserted into one of the cavities for illustration. The cylinder is now shown in the gun frame. This Tround cavity is located 90 degrees away from battery. As the cartridge is pressurized during firing, the cylinder is forced to bear against the opposite strap, transmitting the load back to the frame and closing the force loop. Pockets on the periphery of the cylinder serve to reduce weight and inertia, thus minimizing power requirements. Assembled to the rear of the frame is the cam index drive, or CID. The CID's function is to rotate and precisely locate the cylinder during automatic fire. Located on the end of the input shaft is the firing pin cam. For each gun cycle, the cam makes one rotation, compressing the firing pin spring and cocking the hammer. At the fall-off point, the spring energy is delivered to the firing pin. Following a short dwell time, the firing pin automatically retracts to allow for ejection of the case. Because the cylinder comes to rest during each cycle, the CID must convert the constant rotary motion of the input camshaft to a smooth acceleration and deceleration of the cylinder. In this scene, the cylinder is turning at an extremely slow rate. Note the rotation and dwell phases of the cam follower wheel and cylinder, while the cam continues to turn at a constant rate. The cam appears in the upper portion of your screen, while below is the cam follower wheel, which is connected directly to the cylinder. The CID cover has now been added, as well as the motor and the speed reducer. This completes the drive system. In this configuration, a 28-volt DC motor with internal brake is used, although other external power sources may be utilized as well. The gun's rate of fire is equal to the input shaft speed in RPM. The speed reducer gears down the motor's 8 to 10,000 RPM speed and multiplies the torque to that compatible with the gun's requirements. The feed and ejection guides have now been attached to the frame. These guides serve to positively control the ammunition in its path through the gun. The end guides set fore and aft limits, while the lower guides ensure a smooth transition into the Tround cylinder cavity. The lower guides also provide the attachment point for the ammunition container to be described later. Lastly, the upper guides cam the Tround fully into the cavity as the cylinder rotates. Here, a dummy Tround is shown in the feed guides to illustrate their relationship. Recoil forces are reduced to levels compatible with the gun platform through the recoil adapter. The gun recoils along these sliders, compressing coil springs and dampers. Counter recoil forces are also reduced through coil springs. The elevation trunnion is on center line with the barrel, so that firing forces cause no tendency for muzzle climb. The safing handle appears in this view in the safe position. To arm the gun, simply raise the lever, turn it 90 degrees, and depress the lever. A spring retains the handle in the down position, where the locking lugs prevent movement from the selected position. The grip assembly bolts to the recoil adapter and provides dual triggers for two-speed operation. Depressing either trigger independently selects the low firing rate. Depressing both triggers simultaneously selects the high firing rate. A portion of the ammunition handling system has now been attached. This section represents the conveyor element. With the access door open, the extended pin roller chain is visible. This chain transports live rounds from the ammunition container to the gun cylinder. It is driven by this sprocket. The balance of the ammunition handling system consists of a storage container and tape mechanism. 110 Trounds are stored in bulk form within the box on top of the tape. During operation, the tape pulls the Trounds upward into the conveyor chain. Through a self-timing gear and slipping clutch, the tape is wound upon the spool. For manual tightening of the tape, a simple hand wheel is used. The ammunition container is shown attached to the conveyor. It is hinged near the gun. The conveyor chain is now moving in slow motion. The upper strand moves outboard, while the lower strand moves inboard toward the gun. The driving sprocket is shown here. Dummy Trounds have been loaded into the ammunition container, which is shown attached to the conveyor. As cycling begins, we see how the Trounds are kept in contact with the chain through the action of the tape. Although the Trounds are randomly oriented, their geometry allows them to neatly fill each chain pitch. Cartridge case ejection occurs on the right side of the gun and is effected by a two-stage passive pin system. The spent cartridge case contacts the inner pin, which cams it radially out of the cylinder cavity. The outer pin and guide serve to further control its path, as illustrated here in slow operation. Once assembly and checkout were performed, the system underwent extensive indoor remote testing to verify its performance and reliability.
Okay, here we go.
Once indoor functional and safety tests were completed, the system was tested in its crew-served environment. The following scenes display these impressive results. The Tround gun system, a new innovative technology for ground and airborne applications.